welcome back to Timberwolf Tutoring. I'm Robin, and today we'll be going over L'Hôpital's rule. And in case you're wondering, that is how you pronounce it, L'Hôpital. It's a bit weirdly spelled, but you'll get used to it. Anyway, so the overview for this video is, we're going to start by defining L'Hôpital's rule and figuring out when to use it, and then we're going to go over 3 practice problems. The third one will be quite difficult, as a warning. So the conceptual bit is, L'Hôpital's rule is basically a method of calculating limits that you couldn't calculate normally. And you use it when the problem, usually it'll take this form, although sometimes you'll have to convert it to this form, which you'll see on problems 2 and 3. And then the rule states that if the limit yields an indeterminate form, and indeterminate forms are things like 0 over 0, infinity over infinity, 1 to the power of infinity, 0 to the power of 0, infinity minus infinity, stuff like that. And if the limit yields one of these indeterminate forms, then you can rewrite the limit like this. So f of x over g of x is equal to f prime of x over g prime of x. And this lets you calculate limits like the ones you'll see in these following problems. So here's an example problem right here. We have the limit as x approaches 0 of e to the 2x minus 1 all over x. So if we plug in x to this, we can see that we'll get 1 minus 1 over 0, which is just 0 over 0, that's an indeterminate form. So we can't evaluate this limit normally, we wouldn't get a right answer. We have to apply L'Hôpital's rule, and when we do that, we take the derivative of the top, and we take the derivative of the bottom. We don't use quotient rule, to be warned, we only take the derivative of the top and bottom as separate functions. And we get that this is going to be equal to 2e to the 2x all over 1, which is equal to 2 over 1, or 2. So our answer for this problem is going to be the limit is equal to 2. And our problem 2, we have the limit as x approaches 1 from the right, and the from the right doesn't really matter that much, but it's just there because it's there, of 1 minus ln of x minus 1 minus over x minus 1. And both this problem and the previous one are from the L'Hôpital's notes that we did in class, assuming you're in the class. But yeah, that's why it's limit from the right instead of just limit. So again, we can't evaluate the limit normally. It's an indeterminate form, 1 over 0 minus 1 over 0, or infinity minus infinity. So to use L'Hôpital's rule, we have to convert this into a single fraction, f of x over g of x, or otherwise the rule doesn't apply. And so we cross-multiply the two fractions to get a single fraction, and we get x minus 1 minus ln of x all over x minus 1 times ln of x. Then we take the derivative of top and bottom, and we get 1 minus x to the negative 1 all over x times ln of x plus 1 minus x to the negative 1. And you may want to look at this for a second to figure out where all these terms come from. But basically the top is we derive both of them separately and subtract them. And on the bottom what we do is we use the product rule. And yeah. So now if we plug in x equals 1 to this, you might notice there's a problem. We get 0 over 0 again, which is still indeterminate. But thankfully we can apply L'Hôpital's rule a second time, and this time it'll work out. And what we get is, this time we get x to the negative 2 over x to the negative 1 plus x to the negative 2. Plugging in 1, we see that it's going to be equal to 1/2. So this limit will evaluate to 1/2 as x approaches 1. So now, this third problem, and before we start doing this problem, I'm going to give you a disclaimer. This problem is much, much, much harder than any problem you'll probably see on the test. So pause the video anytime you get lost, and if you don't understand this problem, don't worry too much about it, but if you do, then you should feel very confident about doing this on the test, because this is much harder than any problem you will see. If you can understand this, you can understand anything. So, if we plug in x equals 0 to this just normally, we would get cosine of 0 is 1, and the exponent goes to infinity. So we have the limit goes to infinity. And 1 to the power of infinity is indeterminate form. So once again, we can't evaluate this, but the problem is this is not a fraction. It's not f of x over g of x. So we can't just use L'Hôpital's theorem on it, we have to rewrite it first. So, the way we're going to do this is very clever, and what we have to do is take a logarithm of the entire thing. So let the answer to this problem, or this limit, be equal to z. So then we write this, z equals the limit of this, and then we take ln of z, and we get ln of this thing, and then we can use our rules for ln to bring out the 1 over x squared, and we get that ln of z is equal to ln of cosine of 2x all over x squared. And now we can use L'Hopital's rule to evaluate this. So now we solve for ln of z, and we get that this is equal to negative 2 sine of 2x over cosine of 2x all over 2x by taking the derivative of top and bottom. And this simplifies to negative tangent of 2x over x. So now, plugging in x equals 0, we once again get 0 over 0, more indeterminate forms. We apply L'Hopital's rule a second time, and we get this nice expression. This becomes negative secant squared of 2x over 1. Secant squared of 0 is 2, so this is going to be negative 2. And that's supposed to say negative 2 secant squared of 2x, sorry about that. But it becomes negative 2. And so now, all we have to do is ln of z is negative 2. So solving for z, raise e to the power of both sides. We get e to the power of ln of z is e to the power of negative 2. And e to the power of ln of z is just z. So we get that z, our answer, is e to the negative 2. So to summarize what we did, we rewrote the problem as a fraction using ln. We applied L'Hopital's rule twice to find the answer of negative 2. And then we undid ln from the beginning to get our answer, z. And, again, I'm sorry that we're missing a 2 here at negative sec squared of 2x. It's supposed to be negative 2 sec squared of 2x. But, anyway. So, thank you so much for watching our video. It means a lot to us. And if you want to contact us, we are available through email at timberwolftutoring@gmail.com, or you can find us on Instagram at Timberwolf Tutoring. And let us know if you have any questions or comments about this video, or if you want to see another specific topic of your choice on the video. Please let us know. And thank you so much for watching. I hope you have a great day. Until next time, this is Robin signing off.